Good morning, everyone. It is now 1 a.m. on Wednesday, August the 5th. Welcome to a special live stream for the Fort Worth Astronomical Society. I'm in a new place right now. I am currently at the Thompson Observatory at the Southwest Adventist University in Keene, Texas. We're just south of Fort Worth, about half an hour or so, and near Cleburne, Texas. There's a very nice observatory here, uh, and I am set up here instead of being set up at the house. Um, Today we are going to watch, hopefully, everything goes well. We're going to watch a SpaceX second stage booster crash into the moon near Einstein Crater. The expected impact is at 1:35 and 37 seconds Central Daylight Time. So we still have some time, we have plenty of time. And I am just sitting here looking at the moon. So currently, if I can get this up, there we are. We're looking at the moon. It's the current live view. The moon is actually very low on the horizon. We're going to wait for it to go up a little bit higher. The view will be a little bit better at that point. Let's see if I can get this right. There we go. Seems like every time you move a telescope, you always move it in the right direction the first time, and then you get it right the second time. Always going to happen. Okay, here we go. Okay, so we're looking at the limb of the moon right now, as it is hanging very low in the horizon. We're going to be looking at Einstein Crater. We can't make that mistake. Einstein Crater is right about here. So this is where we're going to be looking. Centered out just a little bit. And it's never in the right place. Okay, here we go. So somewhere here, somewhere here along the center is where we expect it to land or to crash. So this is a second stage. This is not the primary. And this was second stage was used to launch a lander from Firefly Aerospace in January of 2025. So it's about the size of a school bus, weighs about I think 40 tons. Or is it 4 tons? Uh, 4 tons, only 4 tons. But it's going to hit at about 5,400 miles an hour. It's about 8,700 kilometers an hour. So it'll be pretty fast. The expectation is that it will kick up a plume of dust. Because it's on the sunlit limb, we probably will not see uh, any flash of light. It'll just be too bright and the actual impact will be too small. What we're going to be looking for is in the minutes afterwards, a plume coming up from the moon surface right along the limb here. We should see something, hopefully. So that's what we're going to be looking at. If you can hear me okay, just let me know in the chat. I think I've got the audio right. Camera settings look okay, and everything should be fine. All right. So again, currently we are not at my house. We are not at the Fort Worth Astronomical Society's dark sky site. We are down in Keene, Texas at the Thompson Observatory at the Southwestern Adventist University. One of the reasons why I wanted to come here is because everything is set up. I don't need to set everything up at the house. It's a very nice observatory. There's a very nice telescope, and we are using a 10-inch apochromatic refractor. This is a TMB APO, TMB APM. Very, very nice setup. Jerry here is the director of the observatory, and he graciously has let us use it for tonight. And as soon as this is over, about 2 o'clock in the morning, we'll go ahead and stop. I think it's a little bit echoey. Unfortunately, I can't get it any better. I have a single microphone here. The actual building itself, it is um, the dome is metal, so it will echo. There's not much I can do about that. And you can see on the picture how it is. So the sound goes up and it travels right back down. This is the best I can do. There's also some very loud equipment. I'm trying to filter that out as best as I can. So a 10-inch telescope. This is on a Paramount ME mount, software bisque. It's a very, very nice mount. This mount can actually handle up to 200 pounds for imaging. And the telescope itself weighs quite a bit. I'm not sure how much this one weighs. At one point, we had a 8-inch TMB APM Apo, and that weighed 108 pounds. This is a bit bigger, so it's going to weigh quite a bit more. But I have a camera on there, and we are just about, I mean, we're ready to go right now. We're pretty much just waiting. So let's go back down, and yeah. So what we're looking for, and this is at 1:35 and 37 seconds, so we still have some time, just over 25 minutes, I think. Yeah. Before, yeah, before the actual impact. So um, we're going to wait. If you have any questions, go ahead and put them in the chat. I am monitoring it and I am recentering this. The setup here is very, very nice, but it's really set up for visual astronomy. It is not set up for astrophotography. So when I get done with this, I'm going to talk to Jerry about it and see what we can do to make this a little bit more uh, astrophotography friendly. You can see a few things that can be done just right off the bat, but this will make it easier to do live star parties like this in the future. This is a really nice setup, working as it should be. Um, we're just waiting. We're just waiting. So, is it going to crash exactly that time? That is the calculated time. We do have, because of the distance to the moon, it is a 1.5-second delay. But again, when it crashes, we probably won't see any flash. At this time, I have a 60 millisecond exposure on this image. About 1:35, yeah, at 1:35, I will go and start recording. I'm going to be doing 10-second, basically a 10-second movie, just recording as much data as I can through the impact and then afterwards, because I want to be able to uh, try to find that plume. So right now you can see the image. Let's zoom in on it. It'll make it easier to see this way. This, yeah. Um, because the moon is still very low in the sky, the image quality isn't that great. We're seeing through a lot of the atmosphere. When we do, it's well, it's kind of like looking through water, um, through a thin sheet of water. Every once in a while, like right now, we have a really good image. It's clear. It's clearing up a bit. You can pick out some more of the details. For example, here we can see some of the rays emanating from this crater. We can see additional rays. We can see some rills through here. The craters are coming in a little bit more clearly, but it is jumping around a little bit, and that is because of the atmosphere. Not much we can do about it. The atmosphere is always going to be better the higher up an object is in the sky. We don't typically do imaging when something is this low. Unfortunately, we don't have a choice. This is kind of this is going to happen when it's going to happen, and what we get is what we get. So as the moon goes a little bit higher, we're going to be seeing it a little bit better. I think the focus is as good as I can get it with this scope at this time. So I'm not worried about getting it a little bit brighter or a little bit sharper. In terms of brightness, this is kind of what I want. If you look down here, you can see on the histogram, I am peaking a little bit in the red. So I will probably, in a few more minutes when the moon gets a little bit higher, probably about 120 or so, I'll drop the exposure down a little bit more because I don't want to be clipping my histogram. What that means is um, when you see this little bitty peak here in the red, that means that it's losing data. Uh, some of that red is just it's white essentially. So we don't want that. We want a histogram that ends right about here or so. So we have the greatest amount of graduation between black and white. And from that, we can play with it. We can stretch the histogram in different ways and we can pull out details. So I use that kind of stuff all the time with solar imaging, hydrogen alpha imaging. We can use it with lunar as well to really bring out the details later on. So this is zoomed in. This is pretty much as sharp as I'm going to get it, um, but it's looking good. Hopefully, we'll be able to see something. Worst case, you can always just bump up the exposure and see if something's popping up somewhere here on the edge, but not right now. What I mean by that is I can do instead of 60 millisecond exposure, I can do 250, and ooh, you can see it clips it right there and everything is just bright white. That's definitely not what we want. So 1/60th of a second, way too dark, and the histogram is way down here. So all of this area here is data that could be filled, but it's not. So we don't want it, we don't want the exposure too fast. We don't want it too slow. This is 66 milliseconds. We'll probably drop this down to 50 milliseconds. Yeah, oops. We'll do 50. And at 50, that gives us a tiny bit of clipping. And probably drop it down to 45. Yeah. So we'll do that. We'll drop it down to 45 and then keep it there and get ready for the impact. 45 milliseconds. There we go. See, we're no longer clipping down here. Much, much better. So this is kind of dodgy here. Oops, a bit of a dodgy setup. Only because the computer that actually controls the mount is not connected to the internet. It doesn't have an imaging camera on it. So I'm having to kind of play around with it a bit. My camera is attached to the telescope and it's coming down to my laptop so I can use it and connect it to here so we can actually see what's going on. I actually switched out the cameras. I have a 2600 and was it ZWO ASI 2600 color, but when I tried that one, it's a very large chip with larger pixels, and I saw much more of the moon, but I didn't get that fine detail on the edge. So I switched this out for my ASI 183 MC Pro, and this one has a much smaller chipset, uh, or a smaller imaging sensor, but also it has a smaller pixels. This lets me get finer details. I've done lunar imaging with this camera before, and I really like it. So by swapping it out, I get a more cropped version of the image, a tighter view on the moon, and hopefully better detail for this. So I have some questions. Why isn't SpaceX streaming their own mistake? SpaceX is a rocket company. They're not a telescope company. So they may not really have too many people uh, who have telescopes pointed at the moon to do this kind of stuff. Uh, Second, I just don't think they're set up for this. So they don't have any in orbit assets that would be looking at it. Like SpaceX is a rocket company. They are not a space telescope company. So they're not going to do that. Um, the Einstein Crater, let's see. John is asking where the Einstein Crater is, and it is right about here. Yeah, right about here. So this is where Yeah, because I'm looking at the another image, and it's got the libration kind of off. So as close as I can tell, take this crater to this line, and it's Einstein is right here, rough, roughly, yeah. So it's a crater that's very close to the edge, to the limb of the moon. We don't see it very well from the Earth at all. Um, we can see it very well with orbiters, and there was actually an orbiter that went ahead and um, uh, they imaged this about a week ago. They imaged the Einstein Crater region about a week ago, and after today's impact, they're going to use the Lunar Reconnaissance Orbiter to again image and see what they can see. The expectation is that it's going to be a crater about 60 feet, 18 meters wide, about 12 feet or 4 meters deep, and throw out dust and rock as it be ejecta. So, with the Lunar Reconnaissance Orbiter, they should be able to see some of that eject on the surface. Hopefully, they'll be able to see the crater. It's good sized. Let's see. Yeah, it's just really hard to see from where we are on the Earth. Are we going to catch a good view from it? Good view of it? I hope so. I mean, I would not be here if I didn't think that it was a good possibility we could catch something. The expectation is it can throw it up about 100 miles, but the plume could go 100 miles above the surface, in which case that would be, uh, let's see, 100 miles, about right there from here to here. So that's assuming that it's an impact straight down engines first. This is a booster. So the booster is mostly empty. It is out of fuel, weighs 4 tons. The skin of it is fairly thin. A rocket only needs to be just barely strong enough to hold together for the trip. It doesn't need to be over engineered. So the heaviest parts are going to be the engines. We don't know if it's going to impact on its side. It's going to impact engine first. How it's tumbling, we don't know. The simulations have all been a impact straight down, perpendicular to the surface, engines first, and the calculations for the calculations for the plume going straight up were from that expectation. If it impacts at an angle, the plume may be smaller. So again, we don't know. We'll find out. Let's recenter this. One of the things I've got to mess around with this is that the um, uh, the telescope, well, I should say the mount is not properly set up yet. That needs to be done. The paramounts have a neat thing called T-point. You can point it all around the sky and say, take an image and center it and say, okay, this is this star at this position, and then it remembers everything. You train the mount on the sky, and then it has very, very good tracking. You don't even need a guide scope to do it. Unfortunately, this mount has not been calibrated with T-point, so it's um, yeah, it drifts. So I'm going to have to do corrections. Hopefully, I don't have to do many corrections before the or during the plume development. Crossing our fingers, hoping for the best. Do we know what speed the impact is going to be? Yeah, that was 5,400 miles per hour, or about 8,700 miles per hour, is how it's going to hit. So, um, yeah, should be fun. Okay, everyone joining us late. I'm Chris Moditsky with the Fort Worth Astronomical Society. It is 1:20 a.m. on a Wednesday, and normally I would be in bed cuddling with my wife. Um, and she's probably not terribly thrilled that I'm not doing that right now. But this kind of event, it only happens every once in a while. I don't remember the last impact like this, but it's an opportunity, and you just can't kind of just let it pass if you have the ability to do something about it. So yeah, here we are, live streaming and just waiting for the impact. So we've got another 15 minutes till it starts. If you are at home, if you have a big enough telescope, if you have a high enough power on your telescope, take it outside, take a look, see if you can see something naked eye. Um, don't know if it'll happen. Don't know if it'll be visible naked eye or if it'll take some processing to bring it out. I will not be doing processing tonight. I'll worry about that in tomorrow evening. I have work in the morning, so I need to get as much sleep as I can before I have to get up to work. Okay, we have a brightening moon. It is rising higher up in the sky. So we're looking through less and less atmosphere. Because we're looking through less atmosphere, the moon is less red, uh, less orange when I looked out at it before, but also becomes brighter. So I'm going to have to lower my exposure a little bit more. I have it at 45. Probably have to move it down to 40 milliseconds. And then, yeah, less than 15 minutes, and we're going to have an impact. It is, oh, hi, we have someone from India right now. Cool. I have a whole bunch of guys on my team from India, and I don't know if they're watching right now. I don't have my phone to ping them, but they'll see it tomorrow or in the afternoon your time. Do we know the size of any of the craters we can see from here in comparison to how big we can expect the dust plume to be? Okay, 100 miles or 90 miles or so is the expectation, and that's going to be about this far. The tip of the cursor from the limb, that's about 90 miles. So if we see something, it'll be about that high. Again, we just don't know. We don't know if it'll be visible just through bare imaging like this. Now, I've taken, for any astrophotographers, I have taken no darks. I have taken no biases. I have taken no lights, light frames. And that is because this is the first time I'm using this scope. I came out here when it was already dark. I didn't have an opportunity to take any lights. I haven't taken any darks because I do not know, uh, or I did not know what exposures I would have, what settings. So I will take my darks afterwards, like a good astrophotographer does. As far as my lights, yeah, I have no idea how I'm going to do those. I'm not going to worry about lights. The dark ones, the dark frames I need so I can get rid of some of this noise. Um, but yeah, that's about it. Looking at my cooler, yeah, I'm at -6 degrees Celsius. It's a lot cooler than it was earlier this evening. I have a nice breeze coming in from the open door. You're next to me. Unfortunately, I can smell skunk. We are out in the country. I did hear a coyote earlier. Even though it's the city of Keene, it's still out the ways. So yeah, I got to. There's a bit of Otis skunk going on in the observatory today. It's hot, but it's warm. It is dry, and I need more water. All right. So we've got people from India. We've got people from New Zealand. Oh, that's nice. Um, and over from Allen, north of Dallas. Cool. Okay, the telescope that we're using for all the newcomers. This is a 10-inch TPM, TMB, sorry, TMB Thomas M. Black APM apochromatic refractor. It's a triplet. 10-inch. It is a big scope. It is on a Paramount ME mount, a big mount, and it's a good sized dome here. And we are at the Thompson Observatory at the Southwest Adventist College, or sorry, University in Keene, Texas. I'm out here all alone. I had hoped someone would be here, but I had a family emergency, wasn't able to join me. So, as I say, all alone. Nobody loves me. Nobody cares. But I have everyone else over here. So cool. All right. We are at 10 minutes till impact, 1:25 a.m. It's coming. If you have any questions, um, go ahead and put them in the chat. We'll answer them as best I can. Again, the impact is at 1:35 and 37 seconds Central Daylight Time. So not too much longer. 45 seconds is too long of an exposure. Let's cut this down to 40 milliseconds, a little bit darker. There we go. I like the histogram there better. That looks fine. What's roughly the area of the impact? As close as I can tell, because my map is a little bit off, it's going to be, let's see. Yeah. Where this bright area is, this is the Einstein Crater region. So we're going to be looking for the plume somewhere in this area. I don't know exactly where it's going to impact. We were just told that this is the general area of impact. So, oh, that's nice. Oh, SpaceX does have a live view. Ah, cool. So something that's really interesting that we found out actually at our club meeting a couple months ago is well, one of the reasons why the Lunar Gateway program, the space station that was supposed to orbit the moon, was canceled. And that's because of dust. So when you land a big lander on the moon, the thrust is coming out at several kilometers a second. Well, the escape velocity of the moon is about 3 kilometers a second. So if your engines are blasting out propellant or reactants at, let's say, 5 to 7 kilometers a second, you are blasting lunar regolith, the dust, out at very high speeds, even at escape velocities. So every time you land, you're blasting lunar dust all around the moon. So one lander can actually throw lunar dust around the entire moon and have it come back to the landing site, which sucks. So basically, you're sandblasting everything on the moon, including assets in orbit when you land on it. So that's not good. Okay, is Carroll Crater visible in this view? I have no idea where Carroll Crater is. I am not, let's see, I am not, I'm not a lunar expert. I'm not a lunar visual observer, so don't know what I can do. Okay. And we do not have time for me to go looking. It is 1:29, so we have just over 5 minutes before this thing happens. Oh man. Oh, that's lovely. We have 1,000 viewers. So, as the kids say, like and subscribe. It does actually help the algorithm and gets the other videos uh, higher in the views. And if we get a lot of views, a lot of new subscribers, that is just more of an incentive for me to do more live streams. If you are in the Fort Worth area or the mid cities, anywhere in the Metroplex, and you wish to join the Fort Worth Astronomical Society, you can join us at fortworthastro.com. We have meetings on the third Tuesday of every month, and we have a dark sky site about 2 hours west of Fort Worth. It's a very nice site. We actually have a remote observatory there that we had a bit of damage from a lightning storm, but we are fixing up. And when we do, it will be available for the remote use for our club members. We have a bunch of telescopes out there. I think we're at 80 telescopes in total. So even if you don't have your own telescope, you can actually go out there. You can borrow a telescope. You can check it out as a library scope. bring it back to your house and use it along with eyepieces. So you don't necessarily have to have your own in order to join the club. Okay, where's the impact site? The impact site, it's going to be somewhere in this area here. So there we are. Okay. It's going, it's going. All right. Uh, One of my friends, Naz from Nastronomy on YouTube, he was going to be doing a live stream, and he said his weather probably wasn't going to be very good. So luckily here in Texas, we have clear skies. Today is actually a really good day for viewing. The sky is pretty steady. It's looking a lot clearer than it was earlier. It is 1:31. We've got another 4 minutes. So yeah, we are almost there. Let's see if I can bring this up. So I want to get a second timer on this thing. Load up my phone. Let's get a clock on my phone. Alarms, timer, stopwatch. Just world clock. Okay, 1:31, 1:32 now. Also, we do have a about 20 to 30-second delay on the YouTube stream. So your clock will say one time, my clock will say another one. So it's just a natural delay in YouTube. How high will the plume be? We're looking at anywhere from, well, the expectation is perfect scenario 90 miles. We don't know if it'll get that high. It'll be whatever it'll be. So, que sera, sera. When is the impact? 1:35 and 37 seconds. Central Daylight Time. So just a few more minutes. Just waiting. How confident am I that my setup will capture it? I'm doing the best I can, man. This is a 10-inch Apo refractor, and I have a ASI 183 MC color on here. I'm able to record pretty fast. Ooh, we got a satellite crossing right there in the black. There we go. That looks just like a satellite crossing the moon. I didn't record it, but it's on the live stream. Not too bad. We can see that kind of stuff every once in a while. But that was actually pretty good sized. It was moving in a straight path. It did not look like a bug, did not look like a bird. Didn't look like an airplane either. So that was neat. Okay, cool. All right, how long till impact? 1:33:45 seconds mark. So just a few more minutes, basically under 2 minutes. Under 2 minutes, under 2 minutes. Okay, so I got to get ready. Focus is good. We're going to call this moon impact. And I'm going to start getting ready to do the start capture. When I do the capture, here we go. No, not start capture, do capture. Here we're going to do the start capture because I'm going to do 10-second exposures. And on here, I'm going to do, let's call it 150 sequences. So what happens is I'm going to get 150 files, and each one is going to be a recording of 10 seconds. 10 seconds of frames, and I'm getting, this is saying about 9 frames a second. Once I start recording, it should drop down to about 7 to 8 frames a second, but that's still good. And we'll talk about processing later on. So 1:34:42, we got less than a minute to go, and I'm going to actually start recording. Yeah, I'm going to start recording in just a few seconds. So, outside Louisiana. Okay, yeah, we're not expecting to see any flash. Hubble can't focus on the moon. Moon is too close for Hubble to focus on, so okay, here we go. I'm recording, starting now. Okay, what's my recording? Good, 9.48. Okay, 6 frames a second, still good. I'm happy with whatever I can get. I'm going to slew this over just a bit. So hopefully, come on. Come on, come on, come on, come on. There we go. Okay, impact any moment. Let's see. So we're looking somewhere along this area here. Okay, we're past the impact time. I don't see anything. Let's zoom in. Hopefully, come on. Will let me zoom? Yeah. So we're going to zoom in 100%. And we're looking. Okay. Oops. Get it up in this area here. All right. If we see anything, it should be in this general region here, somewhere along the edge. Not seeing anything yet. But man, that is a much sharper image than I got before. Just rising up into the sky. It's a good telescope. It's a good camera. It's a good setup. I can make it a little better, but we're good. Okay. Don't see anything. Maybe. I don't know. Let's watch that little bump there. See what it does. This may be one of the things where we have to process it to bring out the details. Yep. So now, here's something else to look at. The expectation is that within the next 10 minutes is how the plume is going to go up. It's not, this isn't Hollywood. It's not a explosion and then all of a sudden a bunch of stuff being thrown up high over the moon. It's an impact. The moon's gravity is 1/6 of the Earth's. It will go much higher than it will on the Earth, but yeah, we're just gonna have to watch it. We're gonna have to record it and probably go back and process it. So right now, I'm not seeing anything. If someone else is looking at another stream, if they're if you can let me know, is anybody seeing any plumes right now? Because I've got nothing. Go up. Yeah. Not seeing anything yet. But again, it's only been just over a minute. So the expectation is over the plume will evolve within about 10 minutes. So we're just watching. This is the primary area, I think. But I mean, I'm watching this whole area to see what's if anything is changing. And I just don't see anything. It could be that it's just so dim that we're just not able to see it. And yep, at least without processing. So luckily, what I can do is later I'll be able to take these images and I'll be able to start processing them. I'll be able to pick out the best frames out of each 10-second movie and then process those, sharpen those. And then I can actually process the edge differently and see if I can see any differences, if I can pull out a plume from there. So what I want is the best of all the images. We call this lucky imaging, where you take a you can actually take thousands, tens of thousands, hundreds of thousands of images of the moon or of planets, and then you only take the best 1%. So if you take 100,000 images, but you only take the best 1%, you still get 100 images out of it. Actually, no, sorry, 1,000 images. Then you process those images, and those are the best ones, and then you can get a very, very sharp, very clear image out of it. So we are, yeah, we're plus, it's 1:40 right now. So we're plus a few minutes, and we're waiting for the plume to evolve if we're going to see anything at all. Don't know. Nothing is really obvious right now. Let's go up a little bit. No, nothing really obvious. That's too far south. Again, if it's going to be somewhere in this area here. and we're just expecting it to come off the limb. I thought that was something, but I don't think it is. Okay, if you're asking what the setup is, this is a 10-inch Thomas M. Black APM Apo refractor on a Paramount ME mount, and a ASI 183 MC Color Pro cooled camera. You speak a little French? No, I speak Polish. So I speak Polish and English. I also speak Texan. I've been here long enough. And I am not seeing anything at this time. So we still have a few minutes. I'm going to wait until probably 1:50, and I'll start recording about 1:50 and then go into processing. And the reason why I say that is because we're expecting like a 10-minute, maybe up to 15 minutes for the plume to evolve. And just because we can't see it right now doesn't mean the plume's not there, that we can't pull that with processing. Okay. A co chcę powiedział? Bym powiedział dzień dobry, ale już jest późno. To dobry wieczór. It's Polish for a good evening. Someone asked me to speak Polish. There you go. Yep, I'm not seeing any plume yet. Once I make a time lapse out of this data, if there is a plume, it may be more visible, because it's kind of hard to tell in here if there's anything that's changing. But once you do a time lapse and compress like several minutes down to something a lot less, then hopefully then it'll be more visible. All right. Yeah. Asking, do I have a Polish background? I was born in Poland. Just been here long enough. I talk like a Texan. My wife is Polish, and we have a kid, and his first language is Polish as well. And he should be in bed. He should be asleep. And if he's watching this, just wait till I get home. He's been staying up way too late lately. Okay, not seeing any plume, not seeing any changes, but it's a really sharp image. I'm happy with that. Let's see, 1:43, so it's been 5 minutes. We need some more time for the plume to finish evolving. So again, I'm going to give 15 minutes roughly, so about 1:50 a.m. So another 6, 7, 8 minutes, and we'll see how that goes. So now the expectation was that we would be able to see something with processing, not naked eye, maybe not even with live imaging like this. So I'm not really disappointed. I mean, I'm gathering data. That's the whole point. So for astrophotography, when we do astrophotography, we're imaging all night. So think about this. When you take a picture with a regular film camera or with your cell phone, how do you do it? You take one picture, it may take 3 or 4 pictures, pick out the best one, and you're done. That's not how we do astrophotography. What we do is we take dozens, hundreds, even thousands of images. We take those images, and they may be long exposure, they may be short exposure, and we go ahead and then process them. We take out the best ones from that group, and we process them. We stack them. The more images you take, the less noise you have in your final images. The longer your exposures are, the deeper the image you can get. And so we will do imaging for several hours in one night, dozens of hours over the course of a week. sometimes hundreds of hours over the course of an entire season, imaging one single object to get out these very, very fine details um, that we really can't see just with a single exposure. Right now, what you're seeing is just single exposures over and over again. And the images they're wavy, they're not that great. They come slightly in and out of focus, and we're not able to see a huge amount of detail. Somewhere over here is where we're expecting the plume. There may be something right here. It's really hard to tell. And I'm still capturing the data. So we're still on track for that 35. Okay, the buffering data, that's fine. Yeah, probably need to do that, but 35 millisecond exposures, that's fine. Okay, we'll see how this goes. Let's see. Okay, so far no one's been able to see anything. Yep. Yeah, for everyone who's saying this is fake, yeah, grow up, children. I mean, really, grow up. This is about, let's see, $50,000 worth of equipment, roughly, uh, just in the mount, cameras, and setup over here. So, no, we don't fake this stuff. There's no reason to fake it. And if you believe that, you absolutely need to grow up. I'm not dealing with flat earthers. Okay, here we go. So it's still recording. That's fine. I'm going to move it over. Yeah. And if you're asking how I'm moving it, I have the paddle right here. So I could just go over to the computer over here and move it, but it has decided to lock up, or not to lock up, to because I haven't touched it for a while. It is, yeah, it's locked, so that's fine. And I'm using the hand paddle instead. Also, there we go. So I can zoom in on the image. This is a 20 megapixel camera that I'm using right now. Yeah, I'm not noticing any differences, but it's really hard for us to notice these kinds of things that evolve very slowly. If you look at the channel, um, I have a solar video, a time lapse from a few years ago. It is 3.5 hours of hydrogen alpha light from the sun, and it is a time lapse, and you can actually see not just the evolution of the sun's surface, but you can see the slight rotation that it does. So again, okay. Uh, all right. Yeah, we're not seeing any plume, just naked eye and imaging like this. That's fine. Again, I'll process it. If there's anything there, then we'll be able to see it. Okay. All right. Do. We'll do this. Okay. And I'm going to. There we go. All right. Okay, when are we going to see the crater? In a week. So whatever crater that forms is on the very limb of the moon. It's also not going to be very big. It is something like, let's see, 60 feet wide and 12 feet deep. So very difficult to see with the telescope, but the Lunar Recon Orbiter will be passing over this over Einstein Crater in about a week, and they're going to try to image it at that time. So, yep, a little bit disappointing, but hey, this happens. I mean, I've been out at the dark sky site before, and all my equipment failed. I got nothing done, and the moment that I just started getting everything just aligned exactly the way I wanted it, the wind came in and shook all my equipment, and yeah, just put everything away. So all done. But today in the dome, got a little bit of wind, um, but it's actually fine. It's coming in from the direction of the open shutters. It's still fine. Imaging is going. It's been just over 10 minutes. If there's anything, I'll have to get it in post processing. I just don't see anything now, but go to bed. Go to bed. I find this interesting. A lot of people find astronomy interesting. So when we do our virtual star parties, I will be usually out at the dark sky site, and we go from object to object to object all night long, or until I'm too tired to go on. And yeah, we do live imaging. We can see what it looks like. We can do live stacking, which takes image after image after image and creates a better version over time as it builds. And it's something that I find enjoyable. It's something that I find enjoyable not just to do it alone, but to share with others. And I find it interesting. And in the end, that is really all that matters. That we find things that are interesting. We learn more today than we knew yesterday, and we learn more tomorrow than we knew today. So go. It is 1:52 and 15 seconds now. So the plume, we should have development of the plume. Um, it is probably falling back as of this time. If it was an impact at an angle, especially at a severe angle, then we wouldn't have a high vertical plume. We would just have a blowout in one direction. It's kind of interesting. You would think that you only get round craters with a direct impact straight down. And it turns out that's not the case. What actually happens is that up to about, I think, 70 degrees off of perpendicular, you will still get a round crater at impact. It's only at extreme angles of something like, I think, less than 30 degrees from the horizontal that you actually start getting elongated craters. There are several on the moon. I'm not going to go digging for them now, but we think there were impacts of between 5 and 15 degrees to get these elongated craters. And sometimes you can see kind of not exactly a skipping effect, but we see that it was a chain of craters in a row from an object that broke up at some point in the past and impacted in a line. So neat things. We can look at that uh, at different time at a different time in the future. Do I see anything? Uh, Not really. I can't tell. And I can say this, when I do solar imaging, very often the prominences, which are very, very bright on the sun's limb, are not bright compared to the actual solar surface itself. So when I do the processing, I have to brighten up limb features separately from surface features to bring out that kind of detail. And again, if you look at the channel, uh, if you look at the videos from last year, I have uploaded a solar time lapse. And if you look at that one, you can see kind of some of the processing that we can do with images like this. This is a really, really sharp image. I'm pretty happy with that. Um, just not seeing a plume in this area. Okay, so it is 1:54. Let's see. I still have a couple more captures left. Sorry, I work in IT. Captchas. It's in the vocabulary. Um, yeah. Okay. Not seeing a plume. Needs to wait for post processing. So I will go ahead and when I stop the live stream in a few more minutes, I'll go ahead and start um, taking some dark frames. Won't take any light ones, but I'll take darks and biases and dark biases. And I will get to processing sometime uh, tomorrow, today. Yeah. later today and let that go for a while. We'll see how long it takes because I'm going to have a lot of data to go through. And once we have that, I can start doing some processing and try to make a time lapse out of it so we can see if there's anything to see. Again, the Einstein Crater is in this area here on the limb. So I'm wondering if this itself is Einstein, because there's Einstein Crater and there's Einstein A, which is another crater within the greater crater. So yeah, somewhere in this area is what we're expecting, but nothing at this point. You want to see the other side of the moon? I don't really have the other side of the moon, but I can do this. So they have a nice wide view. This is Plato. I think it's Plato. Pretty sure it's Plato. Let me jump on and find out. Let's see. You can find some of these. Okay. Now we're going to go here. Copernicus. Sorry, that's Copernicus. Plato is way up there. Okay, so we got Copernicus here. Eratosthenes is here. We have mountain range here. This feature right there, Pythus. No, that's not Pythus. That is Aristarchus. Okay. Herodotus next to it on the edge here. Yep. Okay. We have Kepler right here. And as I keep going, Grimaldi. Yeah, okay. Yeah. All right. I think I stopped recording. Nope, still capturing. Okay. I want to get all the data I can. So it's been 20 minutes. 20? 58, yeah. It's been 20 minutes. So if we have anything, we'll have anything. Do you have any last questions, comments, concerns? Okay. So if you're asked about post-processing, what that means is I take the best frames and I stack them. So the sharpest frames, the ones with the least amount of distortion, I go ahead and stack them. That clears up a lot of the noise. It brings out some of the details. Then I can take that into an application like Photoshop, and I would play with the histogram. So when I do post-processing, I'm not adding any pixels. I'm not adding data. I'm not creating anything from scratch. The only thing I'm doing is modifying the data that's already there, changing brightness levels, may change colors, but the data is still there. There's nothing that's being created from scratch. Everything is still there. And that's something that a lot of lay people don't really understand. They think that we're creating images from scratch, and we're not. All we're doing is modifying the appearance of the data that is there. We are not changing the data itself. So I don't go in there and airbrush any new features. What is there is there. If there's nothing there, then there's nothing there. But all right. Well, it's 2 a.m. I don't see, we didn't see an impact because it was small on the sunlit side, wasn't really expected. We're not seeing any plumes. So it's again on the sunlit side. It's the dust from the moon is not very bright. It is actually quite dark. So you're talking about a small amount of very dark dust being blown up into, well, high up over the moon surface and then being lit up by the sun. Um, Again, post processing, I'll see if I can find anything out of it. But um, the moon is a fairly dark object. It's a fairly matte object. We don't really have much specularity at all on the moon. Um, I have a couple of lunar meteorites, and I have shown them on previous live streams. Uh, the rocks themselves are fairly dark, even though they're bright lunar highland breccia. The silicates in this area, as compared to the basalts in these areas, in the mare, it's still a fairly dark rock. So that's what we're dealing with. All right. It's after 2. Um, if I stop recording, I'm still capturing. Still getting them. Okay. Yep. So we'll see what happens. Not terribly worried. But by this time, the after about 20 minutes, the plume is expected to have fallen back already. Ah, oh well. Since I'm already here, might as well do some more imaging. I mean, moon's not going anywhere. It's a good night, right? So I could do another lunar mosaic. Good scope. It's a good camera. It's a good scene. Yeah, I can drop down my exposures just a little bit more. And again, see what I can see. So once this is done, um, once this is done, we can start on just imaging the moon and doing a lunar mosaic. So what that involves is taking an image of every part of the moon and stacking and processing each portion of the mosaic, and then taking the stacked mosaic subframes and putting them together into one large image. And I've done a 600 megapixel uh, mosaic of the moon before, using my setup at home. So NASA said 3:07 a.m. Eastern. No, it was 1:35:37 Central, or like 6:35:37 GMT. So again, the expected area was, let's see, this region, and not seeing anything. So, okay, bit anticlimactic, but all right. Now, if you're asking about focus, um, this telescope has manual focus. There is a knob for coarse focus and a knob for fine focus, 10-to-1 rotation for that one. It is not automated, uh, but with today's technology, we can actually do a whole automation. We can take things like, we actually connect motors to the focuser. We have the camera on there, and we can actually automate everything from the computer. So we can have it slew to an object. We can have it focus on the edge. Like, let's say when I'm taking an image of the moon, it'll do edge detection. It will move the focus motor and refocus to get the best possible image. Then it'll go ahead and do all the imaging. It can actually do a mosaic for you. And you just set up and let it run overnight. And in the morning, you get your data, and then you can start processing it. For me, this is fun. I've I've always enjoyed this kind of thing. Now it's neat that I'm able to do it. Uh, it's unfortunate that nothing. Not capturing. Well, I mean, we're capturing data, but we're not seeing any plume coming up. Yeah. Oh well. Still a nice night. Fairly cool breeze. I have plenty of drive space free. Okay, 1.8 terabytes free, so I'm not worried about running out of space. When I was doing my solar imaging, I was generating how much over the course of an entire day. I generated about 8 terabytes of data that I then had to process. So, yep, that's right. We don't have none of the spacecraft around that currently orbit the moon. We're in a position to image the impact, but Lunar Recon Orbiter imaged the site a week ago, and the plan is for them to, when passing over the same location in another 7 days, to image it to see where the impact crater is, to see what effects there were. So, okay. All right. We got some flurfs on here. Flat earthers, science deniers, eh, little kids, trolls. Because really it boils down to being jealous because I get to play with toys like this all the time. I mean, even at my house, I have a lot of really nice toys to play with, and I can drag this stuff out and use it. But we also the Fort Worth Astronomical Society also does public star parties. So we have public events at Tandy Hills Natural Area once a month. And when the weather is not very hot, we have public events at Dinosaur Valley State Park in Glen Rose. And we are doing public events, public star parties at the new Palo Pintos Mountains State Park west of Fort Worth, about an hour and a half west of Fort Worth. Brand new park, it just opened this year, and it has very, very dark skies. So if you're in the Metroplex, it's a great place to go out. We have telescopes out there. Most of them are going to be visual. So you can look through the telescope and you can see this for yourself. And one of the neat things is I've been in a situation where I had two ladies who were looking through one of my telescopes, looking at Saturn, looking at the rings of Saturn, and did not believe it was the rings of Saturn. So as they were looking through the eyepiece, I hit the telescope to make it shake, and they could see the shake in the eyepiece. It's not fake. I mean, this is stuff that anybody can do. And we're going to see. Yeah, there we go. So, all right, 208. Am I still capturing? It's still capturing. I can do the stop capture, but we'll let it go. More data is always better. Let's see. Okay. All right. It's been a half hour. Any material that wasn't blasted down to orbit is now fallen back down to the surface. We don't know how much material was displaced, and we can estimate it from the size of the crater. But we'll find out that in next couple weeks when more data comes in. But I will say, on the impact, because we do actually have seismographs on the moon, we should be able to detect the impact because we have detected other impacts from rocks hitting the moon. And using that data, P waves and S waves, we can determine what the inside of the moon looks like, just like we do on Earth with earthquakes. I don't know if you remember your high school geology, but yeah, surface waves don't pass through, or what is it? Uh, yeah, we have S waves and P waves, and one of them doesn't pass through liquids, only through solids, and so, or no, it doesn't pass through solid. So we have a shadow on the other side of the world from the earthquake because of the solid core. And yeah, it's been a while for me, and I am not a geologist, so there we go. All right. So no plume, but post-processing, we'll see what we can find. Again, if you enjoy what we do, like and subscribe. It's just an incentive for us to do this more and more often. And the more people tell me to delete this and to stop doing it, the more I'm going to do this. A little up, a little bit down. Okay. Yeah, it's been more than half an hour. So um new conflicting reports of impact, a new time of 2:42, 30 minutes from now. Well, here's the thing about physics. Um Physics doesn't change, and orbital mechanics are fairly easy to calculate. So uh if we had a time of impact, having an hour's difference is actually huge. And it's yeah, it's just not a thing. Impact time is impact time, and it may be a couple seconds off at the most, but we're really good about calculating that kind of stuff nowadays. Yeah. So I don't see any. I'm looking at news right now to see. Just fine. Such a yeah, all the times are 2:35 Eastern. Yeah. Um, okay, which is 1:35 Central. So if you're watching any other streams, is anybody else saying that they see something? Um, okay. Man, some of you people are abusive. Silly children. Don't be that way. Don't be mean. Be nice. It'll get you a lot further in life. But I don't expect much more for kids. All right. So nope, nobody saw anything. Yeah. Okay. Yeah, Chuck's astrophotography didn't see anything. All right. Cool. So nobody saw anything. All of us who have been recording data, we gotta process it. Let's see. There's something on here I just saw in the chat. When did I get into this stuff? 1997. Not as young as I look. I bought my first telescope, um, and it was a very, very small 4 inch, 4.25 inch, or 4.5 inch reflector on a very, very bad mount. But it got me interested, got me started, and then I built my first Dobsonian, and then I built two more Dobsonians with my father, uh, very lovely ones, and they are still in use. And then I started collecting telescopes, and then I had eye problems, um, and I had to get surgery on my eyes. And because of my floaters, I now just do pretty much all astrophotography. Just looking through the eyepiece, just too many floaters for me to really see anything. Quite annoying. So instead, I do astrophotography. Yeah. All right. The moon is getting higher, and we're hitting that 25. We're hitting we're clipping the histograms. So yeah. Okay. All right. Nobody saw anything. So it's been a bit. It's been more than half an hour. So. Okay. If you are in the Dallas-Fort Worth area and you would like to join the Fort Worth Astronomical Society, you can join us at fortworthastro.com. If you would like to go to one of our star parties, we do have them listed. Our public events, we have them at the Tandy Hills Natural Area, we have them in Dinosaur Valley and Palo Pinto Mountain State Park. If you join the club, we do have telescopes that are available for use at our dark sky site, or you can check them out as a library scope, bring them to your house. Am I going to be covering the Perseids? Probably not. One, I'm in the city, so we don't see a lot. Second, it's a couple every hour. So they tend to be bright ones, but it's only a couple every hour. And the most effective way to see them is with your naked eye. I could put up a all sky camera, so it's like a 180-degree fisheye, gets the entire sky. But you typically do a recording of that. Record it every, like for me, it's usually every 8 seconds. Grab a frame and then do a time lapse and pick them out that way. Yeah. So I don't typically do those. Do you think we'll see it if they expect a 60-foot crater after impact? We probably won't. So can I repeat it once more? That's why this is a live chat. So fortworthastro.com. You can always go back. So it's a nice thing about live streams and recording them on YouTube. So zoom in bottom left. Okay. Nice thing about data, have all the data. Yep, that's just a mountain on the edge. For the plume, we were expecting like a pillar coming off of the surface. So it still may be there. See, our eyeballs aren't really that good at distinguishing between deep shades of black and then slightly less deep shades of black, like just barely into the gray. We don't have that kind of contrast detail. For example, like we can see the difference between this and this and this, or at least I can with this image. But if there's a graduation through here, if there's a gradient, it may not be that easy to see. Our eyes just aren't evolved for that. So that's what we have Photoshop for. Photoshop, I can go in, I can mess with the histograms, I can change levels, I can bring up the levels on the shadows and in the blacks to find the more detail there. And then I can drop them in highlights and the whites so that they're not overblown. And you get that weird HDR kind of effect that was really popular with real estate photos about 10 years ago. Actually, maybe a little more than 10 years ago. And with that, you can see things that aren't really visible with the naked eye. Neat trick, and I will be doing that once. Yeah, sometime tomorrow. So, all right. Nobody saw nothing, huh? Okay, that's fine. Let's see. Oh, there we go. Oh. Man, someone doesn't know what a liberal is. That's okay, because I personally am not a liberal. I'm a leftist. And as I get older, I go further to the left. Children, children. All right. Am I still previewing? Okay. I stopped recording, so I'm not gathering any more data. That's fine. We'll do it this way. So this is how we do mosaics. So whatever data we have, you say right now, whatever data we have for the impact, it's saved on the hard drive. Now we just need processing. But it's a nice night, and I'm going to get some more data. So how do I get more data? Oh, I'm going to do this. We're going to look at different parts of the moon. Wrong button. It's always the wrong button. It doesn't matter which button you press, it's always going to go in the wrong direction. Okay. Here we go. All right. So we're getting the northern end of the moon. And what I'm going to do is this. All right. So what we're seeing along here is a terminator, a very gradual line. It's not a sharp line. So I like this. I'm going to boost my exposure just a tad. We're at 25 milliseconds. I'm going to go to 27 milliseconds. And I'm looking at my histogram down here, and I want it to carry over just a little bit higher. So I'm going to do, let's see what 30 does. Might as well. 30. We'll stick with 30. Okay. Yeah, let's go with 30. Okay. So I'm going to do a capture. And what I mean by capture is I am just going to start recording. So I'm going to get a number of frames. You know what? We'll just do a time limit. I'm going to say 2 minutes, 0. And the software I'm using is called SharpCap. And this is a neat piece of software that lets me do a whole lot of stuff, specifically with imaging. So we're going to do 2-minute exposures, and I'm going to call it Moon Mosaic, so that it is a different directory, and 2-minute capture. All right, so for the next 2 minutes, I'm just grabbing frames. Tells me how many I've done, 50 frames so far, 60, 70, cool. So all I'm doing is grabbing frames, grabbing exposures. And when I do this, I'm able to then, in post-processing, pick out just the best frames. So let's say I get out of this, so if we got 200 frames in, see, 30 seconds now I've got 280 frames. So let's say I get 600 frames. If I pick the best 5%, it means I got 30 frames to play with that I can then stack. I stack those images, I get rid of a lot of the noise, and I can pull out some more detail from the image. And then I do the next one, the next one, the next one, the next part of the moon. And then I stitch them all together in Photoshop. And once everything is stitched together, then I can go in and I can play with levels. I can see, I can bring out more features, make them more visible. If you go online and you look up something called a mineral moon, it is a highly colorful version of the moon that brings out the colors in the surface. They're there. They're just not they're not really visible to our eyes because our eyes aren't that great. But the colors are they're there. But the mineral moon effect just enhances them far, far greater than would ever be visible to us. For anyone coming back on, we're not, we're well past impact. It is now 2:24 a.m. and impact was at 1:35 a.m. So not quite an hour after, but yeah. So any impact that was there was not visible. Any plume was not visible. Post-processing, everyone's going to be doing post-processing next couple of days to see what we can see. All right. So right now I just did I'm starting on a mosaic. So I got the northern part of the moon. Now I'm going to try to do the southern part, actually the middle. Okay. So get this part here. All right. It's never the right button. Okay. So I've got this part. We'll do another capture. Another 2 minutes. Let that go. Okay. CR file, good. I want that. Raw 16, that looks good. Looks good. All right. All the other settings are fine. Good. Okay. So I'm capturing a bunch of frames so I can post-process them later. Okay. Uh-oh. Is the stream down? Oh, there we go. It's like I had a blip. Not sure why. Oh boy. Well, looks like I'm having a network issue here at the university. So we are dropping out. Okay. Oh, okay. Well, okay, we're back now. That was interesting. I had a bit of a drop, a lot of dropped frames there for a moment. So not sure what happened to the network. But well, oh well, sometimes it happens. Okay. Exact time of impact was yeah 6:35:37. Yeah, Greenwich Mean Time. So yep, yeah, I'm still getting some dropped frames. Not sure why. Yeah, everything on the streaming computer is just fine. It looks like it was a network issue. It's a network blip. So okay, I got the next mosaic. Let's see, going down, going down. Wrong button. Always the wrong button. And another blip. Not sure why we're having so many blips right now, but we are. Okay. All right. Start the capture. That's okay. I don't need network in order to do these captures. That's fine. Okay. Uh, come on. This is a science channel. We don't need to have religious discussions on this channel. There are plenty of others. All right. Yep. It's been 55 minutes. Yeah, 55 minutes since the impact. We didn't see any impact. We didn't see any plume. Wait for post processing. So, um, if anyone's interested, if anyone has any questions, so go ahead and put them in the chat. If you have any questions specific about what I'm doing right now, we're not looking at the limb. We're looking at the terminator. Let's see. Yep, I'm dropping frames. I don't know why, but the connection is getting worse and worse. Oh, okay. Yep. It is what it is. All right. So the connection is okay. Is my camera on the 10-inch refractor? Yes, my camera is on the 10-inch refractor. Again, this is a Thomas and Black, a TMB APM, 10-inch apochromatic. I believe it is an F9. So it is a very large one. And if you want to see the telescope for new people, this is the telescope. I literally just took a picture of this while I was setting up. So it's got my red lights going on. You can see there's a Batinov mask down here. If you don't know what a Batinov mask is, this is a very nifty little device for getting very, very tight focus by using a star. You put this on the end of your telescope in front of the lens. As the light passes through it, it is diffracted um, as a quantum mechanical effect, and the star that you see has spikes on it. So you change your focus and you get the spike symmetrical in your image, and at that point, it is in focus. It's a very, very nifty tool, and I love it. Use it a lot. Have one for every one of my telescopes, and it makes focusing simple and fast. Okay, still recording. Three minutes. Hmm. Oh, oh, previewing. Okay, so we're done. We're done with that recording. Okay, next we're going to go up further south, down south. So in the south polar regions, we have craters that have not seen sunlight in a very, very long time, possibly ever. Um, and because of that, they are kept very, very cold and they contain water ice. So that is important because that gives us a place to land on the moon and be able to mine for water. However, as we talked about earlier, we do have a problem with landing on the moon. One reason why the Lunar Gateway was canceled is because when you land any lander on the moon, you're blowing dust around at times, actually often, faster than escape velocity. So you have some of the dust which travels all the way around the moon and comes back to your landing site, moving very quickly and acts as basically a sandblaster. Some of the dust actually will get up into lunar orbit and beyond. So merely landing a lander on the moon could have blasted the Lunar Gateway station um, and damaged it. So it was canceled, and now we have to figure out a way to build a dust-free landing platform on the moon so we can actually land there without creating dangerous situations. There's no atmosphere on the moon, so any dust that is blown about um, will go quite a long distance. It will not slow down. Right now, the calculations are that a piece of dust may bounce 5 to 7 times on the lunar surface before it finally comes to a stop. Um, so it can travel quite a ways, like I said, all the way around the moon and back to the landing site. And we figured this out because when just by looking at videos of lunar landers, that when they landed, you could see the dust for a few seconds and then the dust was gone. Well, the dust didn't settle back down on the moon, it was just blown past the horizon because the moon is much smaller, the horizon is much closer than it is on the Earth. And so the dust literally went over the horizon and down and kept going and eventually came back around. So, is the water on the moon fresh? No, not in the sense that you may think of it like water in a bottle. Um, but it's also not necessarily salty. Uh, but it's going to be dirty. It's just dirty water. So it will need to be filtered. It will need to be purified so you can actually use it. Uh, and of course, we have crazy flat earthers in the chat because obviously they have nothing better to do at 2:30 in the morning. That's okay. Go to bed, children. Go to bed. All right. It moved, or I'm going to move it, and let's get this last bit. So here are the Southern Highlands, or sorry, the Southern Highlands, the craters, and down here in the very, very far south, uh, yeah, the the crater bottoms don't get sunlight. So any water ice there stays frozen. Right. We've got this. We're going to do another capture, start capture. And 2 minutes, and we'll go. I mean, I'm here. I might as well. I've got a nice scope, got a good camera. It's maybe going into a rather dangerous position. Actually, you know what? I need to check. I need to check the dome because this dome is manual. So one moment. Where's the scope? Yep. Okay. It's a manual dome, so I have to move it myself. All right, but that's looking really nice. I'm going to zoom in on that just to see. Zoom in close. There we go. Neat. That's a pretty good view too. You can see the atmospheric distortion. It's just the atmosphere. I mean, this is what we get. But this is why we do why we capture a lot of images and why we do the stacking is so we can even out all that atmosphere. We just pick the best images and we process the best images out of it. So the impact did not happen in the dark area. The impact happened along the bright limb, basically at midday on the moon. And you know, when it's that bright, it'll just get lost. You don't see it. Have I seen any structures that were made by a intelligent species? Yeah. I mean, if you look at the Lunar Reconnaissance Orbiter images, we can see the Apollo landing sites. We can see the Surveyor landing sites as well from the earlier moon probes. And what's really neat is we can actually see the tracks of the lunar buggies. We can see the tracks of the astronauts as well around the sites. So yeah, but from a telescope, no. If you wanted to see the lunar, if you want to see like Apollo 11 through a telescope on Earth, the mirror would have to be about 300 meters across for you to have the resolution to see that. So no, it's not feasible. And if you're asking again, can Hubble look at the moon? No, Hubble cannot look at the moon. Hubble cannot focus on anything as close as the moon. So now I'm getting this this way. There we go. Okay. So I'm going to do another capture. Another 2 minutes. So I'm taking a mosaic right now of the moon. I'm taking overlapping images so that when I do the final processing, I get all these different chunks and then I can just piece them together and then I've got the whole moon. The monolith-shaped object on the moon. What? TMA 1? Tycho Magnetic Anomaly 1? Yes, we all saw 2001. That's it. So a lot of the conspiracy stuff like this, here's what I've noticed, and this is really important. If you don't know how certain things work, whenever you see artifacts, you don't know how to explain them. And let me explain exactly what I mean by this. A number of years ago, I want to say early 2000s, there were some videos that came from the U.S. Navy, from a carrier off the coast of Los Angeles, Southern California coast. And Navy confirmed these were legitimate videos. And if you find them, what it is, it's a video taken through night vision telescopes or night vision camera. Yeah, night vision cameras, night vision scopes. And what they saw were these triangular shaped aircraft flying over the ocean. And when you look at them, it's like, well, it's triangular shaped aircraft. When you zoom in, they're little triangles. Well, if you think the camera just takes a picture of what's really there, then you don't know how cameras work. Night vision cameras typically use something called C-mount lenses. These are used for security cameras as well. C-mount lenses have three-bladed apertures. When you take an image of a light source out of focus, it makes a blob. That blob is dependent on the size and shape of the aperture blades. The more aperture blades that you have, the softer those edges are. So, for example, if you have like a really good photographic lens, may have 13, even 17 blades, it makes for a very nice rounded ball of light. Like we call it bokeh in Japanese. It's a very pleasing image when taken like portrait photography. You focus on the person, and then the background is out of focus, and any lights in the back have they're blown out. They're nice little balls. You've seen them before, and this bokeh is very pleasant to the eye. Well, if you have a three-bladed aperture, any lights are going to be out of focus, or sorry, any lights that are out of focus are going to look like little triangles. And we know these are airplanes just flying out of LAX because they have their navigation lights. The Navy didn't lie. They said, yes, these are legitimate photographs, or sorry, these are real videos, but they're not aliens. They're just airplanes. And they look triangular because that's the aperture of the basically the camera that took them. And if you don't know that, if you don't know that night vision cameras use triangular with three-bladed apertures to make triangular bokeh, then you wouldn't know how to really answer that question. Back in the 1990s, there was a UFO, and I use the word researcher in the vaguest and stretchiest way I can, named Richard Hoagland, and he had all these videos of of these giant alien spacecraft, thousands of miles across, that he took from public NASA data from a solar observatory, and they look like UFOs. They're long and they have this like bulge in the middle, classic UFO, right? Well, no, because those were actually image artifacts um, from the CCD chips themselves. If you have too many photons hitting those particular old CCDs, they would overflow onto the next pixel, onto the next row. They could fill up an entire row, and it would just be just white. And what he did is he took those images and he played around in Photoshop in order to get the image that he wanted. But if you think about it, how come every single one of those pictures, that UFO was always perfectly perpendicular to the edges of the image, to the sensor itself? It was never at an angle. It was never 45 degrees. It was always exactly 90 degrees, exactly perpendicular to the edge. And now we can look back at that. We can see, okay, well, yeah, it's an image artifact. So, all right, what happened? So it apparently the apparent impact time was 1:35:37 Central Daylight Time. We are more than an hour past. Didn't see a plume. Didn't see an impact. Didn't see a plume. Apparently, no one else has seen an impact or a plume. So instead, we are man 30. It's too much. That's fine. Okay, it is what it is. Not going to worry too much about it. Instead, what I'm doing right now is a mosaic of the moon. And yep, there we go. So might as well just messing around right now. I've got, here we go. Okay, plenty of images, and I'm taking 2-minute long videos of the moon, capturing all the frames. So this is a 20 20 megapixel camera on a 10-inch apochromatic refractor. What's my perspective on the existence of extraterrestrial life? Uh, it is very, very, very likely. So it's a big universe. We know that there are, in our galaxy, there are, probably 300 billion stars, which means that there could be trillions of planets. And out of trillions of planets, then it is highly likely that some are habitable. Whether there is intelligent life or not in our galaxy, we don't know. We just don't know. We don't have any evidence of it. So we can look at things like uh, large scale structures, and we don't see those. We can look at things like disappearing stars, stars being covered up like with a Dyson swarm or Dyson sphere. There was actually one case a couple years ago of a possible Dyson swarm, and it turned out to be actually the star passing through a dust cloud. We don't see, like, we've only had the wow signal. There have been very, very few signals that we've had no obviously artificial repeating radio signals, no lasers, no masers. We've had natural source masers. We have not seen any artificial masers. We just don't see evidence of intelligent life in our galaxy yet at this time. Now, it could be the dark forest. Everyone's being quiet because there's a predator species out there that they don't like competition and they get rid of it however they can. We may need to be wary about berserkers. You don't know what a berserker is? Think of a von Neumann probe. You know what a von Neumann probe is? It is a self-replicating probe that will travel between stars, land on a rocky planet, and make copies of itself to send off to other stars. And a berserker probe would be a von Neumann machine that comes to a star, finds inhabited worlds, and sends off signals like radio signals, interrogating them and asking them questions and waiting for answers. And if it gets answers that it doesn't like, for example, can you solve this very complicated mathematical question? And the species can solve it. Well, it may have a gigaton class nuclear weapon that can sterilize a solar system. Why? Because that gets rid of competition. So beware the berserkers. And all this stuff is theoretical, hypothetical, I should say. We have had no evidence of any of this whatsoever. So if you're joining us now, the impact should have been somewhere in this area. If it did impact, then, we expect there was an impact, but we didn't see a plume. I've been recording data during the entire stretch. So if anything happened, I will be post-processing the data in the next couple days. If there's anything to see, I'll go ahead and do like a time-lapse video and post it here. So it has been more than an hour, 10 minutes, hour 12 minutes since it happened. And we didn't see anything, but no one else saw anything either, apparently. It's fine. Everyone's going to be processing data, and in a week, the Lunar Reconnaissance Orbiter will go ahead and check to see if there's a new crater there. So the crater's based on the velocity at impact, about 5,400 miles an hour, and the mass of the booster, about 4 tons. We're expecting a crater about 60 feet wide and 12 feet deep. So decent sized. Oops. Right now I'm using the paddle to move the mount so I can Ugh. Ugh. There we go. It's better. So I can do a mosaic. I'm taking a bunch of images of the moon, and I'll be stitching them together later this week to get something really pretty. The moon is legit our greatest guardian. Yes, it is. Why is it? It's because it has blocked a whole lot of asteroids and meteoroids that would have hit the Earth. They hit the backside of the moon instead, or they got flung away. So, yes, the moon is our guardian. Jupiter is also our guardian. Jupiter helped clear out the inner solar system of a whole lot of asteroids just through its massive gravity. So, yep, if it wasn't for the moon, the Earth would have a lot more visible craters and a whole lot less life. Classified photos from Apollo 11. People said there were buildings and large pipes on the moon. Yeah, cool. Show the pictures. I mean, all of it is show the pictures, show me the evidence. And so far, I haven't seen any. And every time I hear these conspiracy theories about, oh, there's all this stuff on the moon, there is no evidence. No one has ever come forward with the evidence, with the photos. So, no, I'm not going to believe anything without evidence. I require evidence. I require good evidence. Yep. Backyard astronomy said we won't be able to see it in the sliding. Well, yeah, because it was basically midday, or it is midday on the limb of the moon. So we're still in a was it waning gibbous phase, and yeah, on the limb it is basically midday. It is very bright. So no, we weren't expecting to see the impact. We're hoping to see the plume, but again, post processing. So we can come out with post processing. Okay, so one anomaly, evidence for ET tech, burned up in our atmosphere, parts recovered, molten pebbles, unknown metals. I mean, what can I tell you? I have a number of meteorites, and here's the weird thing about that. Again, I want to see the evidence. If you go back to June 30th, I did a live stream for International Asteroid Day. And part of it was talking about meteorites that landed on the Earth. I have a lot. And with those meteorites, I actually put them under a microscope. And you can see on the meteorites that the heat of the passage through the atmosphere did not actually reach the inside of the meteorites. We'll get one more here. That the meteorites themselves, the that molten, that burnt outside, and I didn't bring any today. The burnt outside of the meteorite is called the fusion crust, and it's only a couple microns thick. The heat never gets to the inside. So passing through the atmosphere, it goes so quickly that a meteorite the size of your fist, as soon as it hits the ground, it will frost over. Why? Because the inside is still the temperature of space. The whole thing doesn't get molten. Only a couple microns on the very outside. But here's the important thing. A meteorite the size of your fist was about 20 times bigger when it hit the atmosphere. 95% of it gets ablated away as dust. Okay, all that, the bright stuff trailing a meteor that you see, all that is ablation. It all goes away. And what's left to hit the ground is 5%, maybe, of what hit the atmosphere. So 30-meter crater, 60 feet, 20 meters, not 60, not 30 meters, so even smaller. Let's see, meters are coming towards you, solid dot, and then a flash. It is very unlikely that a meteor will be heading right toward you, but yes, if it was heading directly toward you, you would just see it as a quick flash. Chances are, though, if you're seeing a quick flash in your eye, it's something else. You may have eye problems. you may have a detached retina. That is far more likely than a meteor heading directly toward you. Go to the doctor. Now remember, meteors are 50 to 80 miles up in the atmosphere. They're not close. Okay. They're not directly over your head. They are very, very high. And by the time they hit the stratosphere, they're now moving at terminal velocity. They shed almost all of their velocity high up in the ionosphere. And then they hit terminal velocity. So when a meteor the size of your fist hits the ground, it's probably only moving between 200 and 400 miles an hour, as opposed to, what is it, 11 to 72 kilometers an hour, kilometers a second, sorry, kilometers a second, when it hits the upper atmosphere. All right. I think I'm done with my data for the mosaic. I think I'm going to grab one more here in the middle in case I got like missing a square of data. I don't think I am, but better safe than sorry. And again, the impact was over an hour ago. It is now 3 o'clock. Promised my wife I would be home at 3 o'clock. She probably isn't going to be terribly thrilled, but I'm going to take one more image and uh-oh, there we go. Bit of a blip. I think I should have this, but yeah, I'm going to take this image here just so I'm not missing any spot. I've actually done that. I've taken mosaics before and I've missed spots, and it really frustrated me. Okay. All right. Yeah, again, small pebbles of this impact. Okay, well, show me the data. So, when do you usually stay up with the telescope? When I can. I've had an injury for the last year. I've been nursing, so I haven't been able to do it as much because I can't carry that much. Um, but it's kind of a when I have time. And I've actually set up a studio in my office at home, specifically so I can have telescopes in the backyard, do everything remotely, and be comfortable, and not have to sit out in the heat or in the cold. So hopefully I'll be doing that. Most interesting fact I know about the moon. Um, we have lunar meteorites. Um, we have rocks from the moon. I have 3 rocks from the moon, 2 from the same meteorite, 1 from another one. Um, and they are legitimately rocks from the moon. And how do we know they're rocks from the moon? Because we've tested them against the rocks that the astronauts brought back in the Apollo missions, and they match. So they contain some minerals that do not form in the presence of water. The ones I have are lunar highland breccia. Um, and they're very, very neat. And if you want to see some of them, again, the live stream that I did on June 30th for International Asteroid Day, towards the end of the night, I went ahead um, and I have those meteorite pieces under the microscope so you can see them much more closely. So the way you can think of meteorites is they are free sample return missions from asteroids and planets, but it's a random sample. You never know what you're going to get. And still capturing. Cool. There we go. Done. Almost done. Um, so yeah, tell me the time. It is now 2:59 a.m. my time. It is late. I was only going to do this for an hour, but it's ended up being 2 hours. So cool. All right. Um, there we go. Anything? Copernicus crater? Yeah, sure, why not? So I have to wait for the yeah, for the captures. Capture complete. Here we go. Okay. One Copernicus. Here we go. Let's see. There we go. Let's get real close and personal. And all that every few seconds, every once in a bit, the scene gets really, really clear. And that's what we want to record, is that good seeing, those few moments. And we call this lucky imaging. And then we toss out all the bad stuff. We toss out all the frames. Bad frames are bad frames. We don't need bad frames. We only want the good ones. So we keep the good ones. So as we're looking here, we can see the central peaks here in the middle. They clear up every once in a while. We have the edges of the crater. We can see they slump down. So with large craters like this, when the impact happens, I'm going to stand just a little bit. When the impact happens, it melts the material inside. It pushes it all out. But because it's molten, it can't hold structure. So it all starts to slump back. And when it does, it creates these peaks in the middle. They're called rebound mountains. Kind of like if you take a drop of water onto a dish of water or a cup of water, it goes down and then it bounces right back up. When it does that, you see the water coming like this. Well, it's the same thing, except that the rock freezes and cools and slumps down a bit. And the walls slump down because there's no structure down in the bottom anymore. So they're just kind of move in. And yeah, there we go. So this is the larger crater. Smaller craters, they're just round. The material gets blasted out. There's very little, if any, meltage. Only the big stuff that the bottom gets melted and then flattens out. And for some of these craters, some of the bigger ones, they're so wide that if you were in the center, you would not necessarily know you were in a crater because the crater walls would be below your horizon. You could see them again if you landed in a rocket and you took off from the rocket again. If you went higher up, the crater walls would come into view because you're now seeing further past the horizon. But from the middle, you wouldn't be able to see them. All right. Okay, no flash of light. We didn't see any impact. We did not see a plume. Needs post-processing, so that will be later on this week. It is 3:02. It'll take me an hour to break down and pack up and head home, and then I gotta be working at 8 o'clock in the morning. So I'm gonna sign off. I'm still pleased. I'm happy I did this. Thank you for joining me, and have a good morning. It's 3:03 a.m. here in Texas, so go to bed. Go to bed, go to bed, go to bed, and good night.